Problem from friction. Here a block is placed on a surface which is and there is a uh, there is a friction acting this surface, and if we apply the force F, then force of friction in this direction will be acting, and the coefficient of friction is given, that is coefficient of static friction and coefficient of kinetic friction. As we apply the force, as soon as we apply the force of friction start to act on this body, and as we increase the force of friction, as we increase the applied force of friction also increases, and a time reaches when force of friction uh, force of friction becomes maximum, and that is called a static friction, limiting friction. And below this, before this, the force of friction acting on the body is a static friction. When applied force increases the maximum static friction, body start to move with acceleration, and when body start to move at that time, the force of friction acting on the body is kinetic friction. Here it is written, as F increases, static friction F increases, and if body is at rest, then F equals to F. But when F is greater than FL, that is mu s into N, when applied force becomes greater than limiting friction force, that is mu s into N or mu s into mg, uh, body start to move with the acceleration A equals to F minus Fk by m, where Fk is the kinetic friction given by mu k into mg, or F minus mu k into mg by m. This is the acceleration. For example, let us consider a block is placed on the table or any surface, and the value of mu s is given 0.5 and mu k is 0.4. Now we are starting to, and the mass of block is 1 kg, and we start to apply a force on this body. Okay. Then from the formula of lifting friction, FL will be FL is equal to mu s into n equal to mu s into mg, or because mu s is given 0.5, so 0.5 into 1 into 10 equals to 5 meter. That is, this is the limiting friction, that is maximum static friction, and Fk will be mu k into mg equal to 4 Newton. This is the kinetic friction. Now, if the applied force F is less than, if the applied force F is less than 5 Newton, the force of friction will be equal to applied force. For example, if F equals to 1 Newton, force of friction will be 1 Newton and body will not move. So it is called adjusting force. This is the cause that force of friction is called adjusting force. Now when F equals to 2 Newton, when applied force is 2 Newton, force of friction also acting on the body is 2 Newton. When F equals to 3 Newton, force of friction becomes 3 Newton. When F equals to 4 Newton, force of friction becomes 4 Newton. When F equals to 5 Newton, force of friction becomes 5 Newton. Now if applied force is greater than F Newton, 5 Newton, that is considered 6 Newton, then block will move in the direction of applied force with acceleration A equals to F minus Fk by m, or F minus mu k into mg by m. For example, if F equal to 6 Newton, then acceleration will be 6 minus 4, because we have calculated this value. 6 minus 4 by 1, 2 meter per second square. Again, if F equals to 7 Newton, A will be 3 meter per second square. If applied force is 8 Newton, then acceleration will be 4 meter per second square. Similarly, another value can be calculated. So here we see that if applied force is less than limiting friction force, then body will not move. So to move the body, we have to apply the force greater than limiting friction force. that is maximum static friction force. Now, if we draw the graph between applied force and the friction force, the graph will be like this. This is the force of friction and this is the applied force. So, from this will be a straight line till the limiting friction force, and after that, it will the force of friction will decrease, and it will be equal to the kinetic friction. And in this case, the body is moving, and till point A, body is not moving. From graph, it is clear that if F is less than equal to FL, that is limiting friction force, force of friction is equal to the applied force. Or from this is that is y equals to mx. Here m equals to 1, that is slope is 1, because force of friction is equal to 1. We compare this with the straight line equation, then we get y equals to mx, where we replace f as a y and capital F as a, that is applied force as a x, and then slope will be 1 here. That is the slope of line OA equals to tan theta equals to 1, hence theta equal to 45 degree. Also, acceleration will be equal to 0 for f less than equal to FL. Now, second, if f is greater than FL, A will be equal to f minus FL by m. Now, because f is greater than FL, in this formula FL will be changed to Fk. So, A will be f minus mu k into mg by m. Hence, A equals to f by m minus mu k into hg. If we compare this equation with the straight line equation of a straight line, this will be like this: y equals to mx plus c. On a in drawing the graph, we show the acceleration on y-axis and applied force on x-axis. Then the graph will be like as shown in the figure. That is, this point represent where force of friction is equal to static friction. And after applied force, then there will be accelerated to start acceleration motion, and at this point acceleration is 0. That is when applied force is equal to the maximum lifting friction, that is a static friction. Then acceleration is 0, and when the force is greater than this value, that is from here in this direction, then body start to move with the acceleration. Now question: find a force of friction to normal reaction 3 contact force for angle of friction in the given figure. The applied force is 2.5 Newton. Mass of the block is 2 kg, and the static friction between surface of the body and surface is 0.4, and take g equal to 10 meter per second square. So draw the free body diagram. First, the applied force will be in this direction, normal will be in this direction, weight of the body will be in direction, force of friction will be in this direction, and contact force, that is resultant of normal and friction force, will be in this direction. First, we calculate the limiting friction force, that is FL equal to mu s into n. So this will be mu s into mg equal to 0.4 into 2 into 10 equals to 8 Newton. Now F 0.5 Newton is less than FL, that is limiting friction 8 Newton. So the body will not move. Now sigma fx equals to 0. This will give F minus F, that is equal to 0. This implies F equals to F, and so the applied force of friction will be equal to the applied force, that is 2.5 Newton. So the force of friction acting the body is 2.5 Newton. If F is less than FL, then F equals to F in all conditions, that is 2.5 Newton. Now contact force R equals to under root n square plus fx square, or n is 2 into 10 square plus 2.5 the whole square. So directly we calculate the value. Now next, Example, find the angle made by contact force. Second, the magnitude of contact force. Here body is moving with velocity v, and given ma equal to 400 gram and g is equal to 10 meter per second square. Now if we draw the free body diagram, then this will be normal reaction in this direction. Weight of the body will be in this direction and force of friction will be in this direction. Now we have to calculate this value. So tan lambda will be F by N in this figure, because this line will be equal to force of friction and this line is equal to the normal reaction. So tan lambda, this is the angle made by normal contact force. So tan lambda equals to F by N equal to F by mg, because N is equal to mg, and F and the force of friction acting in this case is 3 Newton. So we write 3 Newton divided by 0.4 kg into 10 meter per second square equals to 3 by 4, it will be equal to tan 37 degree. From this we see that if this is 3, this is 5 and this is 4, then this angle is equal to 36 degree and this angle is equal to 53 degree. Now magnitude of contact force R will be equal to under root F square plus N square, 3 square plus 4 square, under root 9 plus 60 equal to under root 25 equal to 5 Newton. Question: what is the coefficient of kinetic friction if A equals to 4 meter per second square? Here if this body is moving with constant velocity v, but acceleration in acting on this direction, that is, we can say that a force is acting in this direction. Now sigma fx, if we draw the force, if we draw the free body diagram, then only on this body only friction force will be acting. So sigma fx equal to ma into x, or minus f equal to m into minus a, or f equal to ma. Now because body is in motion, so kinetic friction will be acting. So meter into n equal to ma. Since f barabar meter into n, meter into mg, so meter into mg equals to ma. So meter equal to a by g, 2 by 5, so 0.4. So the coefficient of kinetic friction is 0.4. Next, how far will block travel before coming to rest? Given the meter is 0.10, as soon as we give the velocity to this body, the friction force will act in this direction. That is because friction force is acting in the opposite direction to the movement, so body will decelerate. Solution: let's consider the body is decelerating with acceleration a and velocity in this direction and force of kinetic friction in this direction. So force of friction Fk barabar meter into n, meter into mg. Now sigma Fx equal to m into x minus Fk into m into minus a. Fk equal to ma, or ma equals to Fk, or ma equals to meter into mg, or a equals to meter into g. Now value of meter is given 0.10 into 10 equal to 1. So acceleration of this block is uh, acceleration of this block is 1 meter per second square. Now we have formula v square equals to a u square plus 2s, because initial velocity was 10 meter per second here and final velocity is 0, that is body come to the rest after traveling distances. So final velocity v equal to 0 and initial velocity is given. uh, Here we have calculated initial velocity is given 10 meter per second. So here v equal to 0 and u equals to 10 meter per second. Now a equals to minus 1 because acceleration is acting in this direction due to friction force, and s equals to 2, this distance is given 2. So using this value in this formula, 0 equals to 10 square plus 2 into minus 1 into s, and this gives s equal to 10 square by 2 equal to 50 meter answer.